Okay, now that we have sort of we're making progress here, what we can do is we can sort of modify these parameters accordingly to try to find an even better combination. So let me show you like how I would consider this. So suddenly we've got the best max depth of 5. Okay, well let's keep in that range 4, 5, and 6, right? Okay, and we're gonna do these one at a time. Subsample shows 0.6 is the strongest. So again, let's keep in that range, right? 0.7, 0.6, 0.5. Now I'm still gonna do a randomized search because I'm looking at a lot of these in combination, but you can also sort of work in these in terms of grid searches. Min child weight gave 3 as the best. So I'm just going in the middle here, really, 2, 3, and 4. We already did the learning rate 0.1. Okay, so we'll up this one to 0.05, and then we'll try 0.2, maybe 3 and 5. Okay, those are kind of close. And then what else do we have? What was gamma here? Gamma was 0.5, so we can try something like 0.25, maybe 1, maybe even 0.75. Okay, and call sample by tree. Look at the call samples nicely working together. So call sample by tree was 0.6. I'll just keep the values in the middle. Call sample by node was 0.4. I can tell you that's an interestingly, it's rare that it's going to be helpful to go smaller than that. I can tell you I'm just going to leave those two maybe. Call sample by level 0.8, so maybe something like that. So what I'm doing here is I'm sort of like trying to consolidate the ranges just a little bit. I'm trying to do it a little bit quickly just to see like, okay, now when you do the randomized search, okay, you're not necessarily going to get an improvement by doing this. Okay, what happened here? Invalid syntax. Where's the lost comma? Seems like they all have commas. Oh, it's inside. Yeah. And the reason why is because when it's taking sort of a random number, like random 20 rows, it might not get this random combination. But you know what we can do? Simply try it again. Okay, and we can find out, all right? So it's going to check for 20 random combinations given this. And, you know, I sometimes will just maybe do this one more time. You can see, yeah, we didn't get better, which doesn't surprise me. And so what you can start to do now is you can start to hold them and actually use a grid search to see. And here's what I mean by that. So what you can do is say, you know what, okay, let's just go with like our starting place. I'm going to hold each of these. So the best max depth is 5. The best subsample is 0.6. The best, I think that they're the ones in the middle. We can double check. I think this one's 0.6. I think this one was 0.4. The call sample by level, let's check it. 0.8. So in the middle. The learning rate, I remember 0.1. And the min child weight, is that the 3? Yep, the 3. And the gamma was 0.5. Yeah, 0.5. Okay, so now I'm holding them, okay? And if I'm going to hold them, what I can do now is just change one at a time. And I can say, okay, given that we got this great combo, now what if I switch max depth and I try them all? Maybe it was the other thing somehow working in combination. You know, you can go big, right? You can go, if you're just checking max depth, go with those. Now, this is only going to search 8, so you could still have random set equal to true because there's less than 20 combos, so it's going to check all of them. Maybe they don't like that. Did we get an improvement? 0.84797. No, we did not. And more importantly, it shows you here max depth is actually 5. Okay, I think it didn't like that we you know, didn't have 20, but we could simply also set it equal to false. Okay, so maybe, you know, What if we look at this and say in combination with subsample now? Okay, I'm just trying to give you like some ideas here. Okay, so what if let's just try them in combination. What if I try now 0.5 and subsample, 0.6, 0.7, 0.8? Does some combination of these work better? Well, if we're gonna do them in combination, let's check how many combinations do we have here? 1, 2, 3, 4, 1, 2, 3, 4, 5, that's 20. That's okay, we could still do that. The point here, to make sure you check all combinations, you can set it equal to false, okay? And so the idea here now is you sort of modify your ranges to look to see if you can find improvements. And you can sort of switch to a grid search. I think this still did not improve. And again, you could always check, well, what's the subsample? 0.6, and the max depth is still 5, right? So, it's kind of interesting. And let me just do one more. Okay, I'm wondering about the gamma and the learning rate. Okay, let's try the learning rate 0.75 or 0.8. That's close. I'm gonna try 0.2. Okay, even just on that, right? Like it's just, hey, if we tweak the learning rate a little bit, and maybe we'll even add in estimators, right, which we haven't checked at all. Learning rate can go nicely within estimators. And let's just see, the 100's the default. Well, what if we try, I like to sometimes just go with these kind of options to see if more is better here. And it might be in this case, but let's find out, I don't know. But here's an additional 9 combinations. And the process in effect continues. And I can tell you, yeah, so we got a really good randomized search to begin with. Looks like it's going to be tough to top, but this is where I turn it over to you. This is how you do it. You can use randomized search CV along with grid search CV to really find nice combinations. And once you have a nice starting place like you do here, now you can go more in depth. You can work harder to see if you can in fact find gains. Your turn. Try to beat that score.